Greetings YouTubers. Today I'm going to show you how to use the chi-square formula for psychological statistics class. Chi-square, or x2, is done by psychology researchers in order to test categorical data. So let's jump into what categorical data is. Categorical data are data that is in categories. For example, if you're testing to see whether someone is or is not pregnant, this is categorical because it's in separate categories. So how can you spot whether something is categorical? Well, some examples of this, such as marital status, you could either be single or married. Sex is either male or female, or hair color would either be brown, blonde, or red. These are categorical data because they are in separate categories, as opposed to continuous variables where you have IQ score, which could range between 0 and 200, GPA could range between 0 and 4, and height could range between 4 and 7. These are continuous because they run on a continuous scale, whereas opposed to categories, they could be in separate categories. So let's dive into how to actually do the chi-square problem. This is chi-square test of independence, and there are 8 steps in performing this chi-square problem. So our step 1 is going to be stating our hypothesis. We have a null hypothesis and we have an alternative hypothesis. Our null hypothesis is going to be saying what would happen if there was no effect in the experiment. So what we're testing for has no effect. The alternative hypothesis means saying that what would happen if there was an effect in the experiment, and what exactly is that effect. So when stating the hypothesis in a chi-square problem, we're going to use the pi symbol. And the pi symbol in this is going to be proportion of. So for our null hypothesis, we're going to be saying the proportion of blonde pregnant women would be equal to proportion of blonde not pregnant women, and proportion of brown pregnant women would be equal to proportion of brown not pregnant. And same thing for the red haired. So that's basically saying up here, as you can see, what we're testing is whether or not people vary on pregnancy rates depending on what color their hair is. So you can see up here at the top for blonde, brown, and red hair, and we have the pregnancy rates of each of them. So what we're doing is we're comparing this categorical data. Our null hypothesis would basically be saying that these percentages between the blonde and pregnant would be the same for blonde and not pregnant, and same for the other types. HA, or alternative hypothesis, would be saying the proportion of getting pregnant versus not getting pregnant will be different for at least one category of hair color, which we can clearly see by just looking at the data that it is. But we have to test whether or not it's significant, and that's the point of the chi-square. So step 2 would be to state our sample size. So our sample size for a chi-square problem is going to look something like this. It's going to be right in the bottom right corner. This is going to be the total number of people that are in the sample. As you can see for this one, we have 97 people that are in this particular study. So all you do for step 2 is put n equals the number of total people that are in the study. So step 3, we need to determine the expected frequency. How do we do that? Well, it's pretty easy, but for step 3 there's actually 3 steps. The first step is determining the expected frequency. The expected frequency is the degrees of freedom, which we'll get to that in a bit, why we're going to need degrees of freedom. This is also known as the sampling distribution. The sampling distribution formula is simply the number of rows minus 1 multiplied by the number of columns minus 1. So for this case, we have 3 columns and 2 rows. So we're going to go 2 minus 1 times 3 minus 1, which is 1 times 2 equals 2. Therefore, our expected frequency is 2, and that's how you do it. Fairly simple. So that's part A. For part B and part C, all we're going to do for part B is we're going to say standard error not calculated. This is because in statistics there's this thing called standard error where we're trying to find our error rate, but this is something we don't have to worry about. We just simply say standard error not calculated. For part C, we're going to say form chi-square with 2 degrees of freedom. This is just simply saying what we're going to form. And that's pretty much it for step 3. Step 4, is stating our level of significance. Most statistical tests run at about a 0.05% significant level, so 5%. This is basically saying that whatever we're testing happens less than 5% of the time. It means that it is significant and did not happen by chance. This is something that statisticians have agreed upon, that if something happens less than 5% of the time, then it's pretty significant. So this is mostly what we test for in statistics. You can use another thing for your significance level, but generally we stay around 5%. If you don't decide to go with 5%, what I'll show you next, I can show you how to go by a different significance level. But all we're going to need to do for this moment is we're going to have to make the alpha symbol equals 0.05. Alpha equals 0.05. Alpha is our level of significance. So, quick review what we should have for an answer so far. For step 1, we have our null hypothesis and our alternative hypothesis stated. For 2, we have n equals 96, so the sample size is 96. For 3, we have our expected frequency, standard error not calculated, and form what we're forming, chi-square over 2 degrees of freedom. And for 4, we set our significance level, or alpha, which looks like a backwards fish, equals 0.05. So for step 5, we're going to take the data that we got earlier. We're going to go over here to degrees of freedom, which is our expected frequency, which we had was 2. So as we can see down here, we're going to look for 2, and we're going to shoot over under 0.05, and we're going to get 5.99. So we're going to need this number. But before we move on, I just want to let you know that if you're going to use another number for your significance level, such as 0.10 or 0.025 or 0.01, you can do the same thing with the degrees of freedom, except go under these numbers. But we're going to stick with 5.99 because we're using a 0.05 for significance. So we're going to take that number 5.99, and that's going to be our cutoff line for our region of rejection. For step 5, you're going to have to draw a little simple graph like this. You're going to draw this, and you're just going to draw this hump, and you're going to make your cutoff line, and you're going to write the number that you got from the chart under it. That's going to be the cutoff line for your region of rejection. You have to make sure you label your region of rejection and label your region of retention, which is this huge area in here. At the bottom, you want to put your expected frequency, and then you just want to write frequencies on the side. So that's pretty much it for step 5. If our chi-square is higher than 5.99, it would be in the region of rejection. That would be our final answer. So say our chi-square was 15. If it was, since that's higher than the region of rejection, then it's significant. If it's below this number, then it's not significant. So step 6 is our largest step, and it's calculating the statistics of interest. This is the largest step. The first thing we must do is calculate the frequency expected, or FE, for each cell. Well, how do we do this? FE, the formula, is going to be the sum of the column multiplied by the sum of the row divided by n. So what we're going to do, say we need to do this for each cell. So the blonde hair pregnant, brown hair pregnant, red hair pregnant, blonde hair not pregnant, brown hair not pregnant, and red hair not pregnant. We need to do that for all 6 of these cells. So for blonde hair, what we're going to do is we need to take its row total, which is 64, multiplied by its column total, which is 30, divided by the n, which is 97, which gives us a frequency expected of 19.79. So I do this for each of the cells. For blonde hair, we have frequency observed. Frequency observed is simply just the number that's already in the cell. So for blonde hair pregnant, its frequency observed is 24 because that was the number that was there in the first place. That's what the researcher observed when undergoing the survey. Frequency expected was its row total times its column total divided by 97, which gave us 19.79. We also did this with brown hair pregnant. 64 times 45 divided by 97 gave us 29.69, and so on and so forth. And I put in purple all these frequency expecteds. I did that for each of the cells. Once you complete that, and this is just showing you where I got each of these, we're going to actually calculate the chi-square statistic. So you need the frequency expected in order to do this for each of the cells. The formula for chi-square is going to be the sum of the observed minus expected squared over divided by the expected frequency. So how do we do this? Well, we take the observed for each cell, so 24, minus its expected frequency, which is 19.79, and divide it by its expected 19.79. It gives us 0.21. We add together each of these for each cell. So we take 31, the original statistic, minus 29.69 squared divided by 29.69 for brown hair pregnant, and we get 0.058. For red hair pregnant, we take 9, its observed frequency, subtract 14.52, its expected, square it, and divide it by 14.52. We do this for each one of these cells, and we add together each one of the answers, giving us a chi-square statistic of 8.25. So there it is. That's the statistic for chi-square. Now that we have our chi-square statistic, we need to make the decision, which is step 7, on whether or not we're going to reject the null hypothesis. Well, since we got 8.25 for our answer, it's higher than 5.99, which means we're going to reject our null hypothesis because it's higher than 5.99. It is outside of our region of retention, not within our region of retention. It is within the region of rejection, as I pointed out on here. So now that we know to reject, we know that it's significant. When we reject our null hypothesis, it means that it is significant what we found, meaning that there was a meaning behind what we found. It wasn't just by chance that people with blonde hair were more pregnant. There was a reason. So saying that, possibly, people could be more attracted to blonde people. Hey, it's not a fact, ladies, but it could be possible. So in writing our results section, what we're going to do, first part of this is going to be writing out our data. So this is simply going to be saying that 24 of the 30 women who had blonde hair, 80% became pregnant. 31 of the 45 women who had brown hair became pregnant, and 9 out of the 22 women who had red hair became pregnant. So you're going to say the number of the first row out of the total became whatever, in this case pregnant, and you're going to do that for all 3. And then you're going to say whether or not it's significant. Well, in this case it was significant because it was higher than 5.99. So we're going to say rate of pregnancy differs depending on color of hair. We're going to write chi-square, in parentheses, the degrees of freedom, equals 8.25, comma, p is less than 0.05. P is less than 0.05 is basically saying that on the scale of significance of 5%, it was significant. And then we're going to write how it was significant. Well, women who had blonde hair were most likely to become pregnant, while women who had red hair were least likely to become pregnant. That was what we found, and we know now that it was significant because we tested it to be significant. This is just kind of showing you where I got all the numbers. So take a good look in this. If you're going back and doing this, you can pause this video, you can look at these arrows, and you can see where I'm pulling all this data from, so you know how to write the results section. Now, what if you had to retain the H0? What if you had to retain the null hypothesis? Well, theoretically, if you had to, I'm going to show you how to write the results. Fairly simple. The first part of it stays the same. You're just going to say the data. 24 out of 30 women had blonde hair, and then for the rest of them, the brown hair and the red hair. And then for the significance, you're going to change. You're going to say you would say rate of pregnancy does not differ depending on hair color. You would write chi-square degrees of freedom, which is 2, equals 8.25, which was our chi-square statistics that we got, comma, n dot s, which would just mean not significant. And you wouldn't state a third part because there was no significance. So I hope that helped you with your chi-square problem. If anything is difficult for you, feel free to go back into the video, pause certain steps of it. I wrote out a decent amount on how to do each step, so if watching the video over once didn't help you, it's okay. Go through, watch it over again, pause it through some spots. I have faith that you'll be able to do it, and it's a fairly easy thing to do once you get the hang of it. I'll try to answer as many comments as possible, and I hope you enjoyed the video, and please subscribe to my channel. I plan on putting many more videos. I take requests, so if you would just make a request, what you might want to see in regards to psychology, and I'll do the best I can. So good luck.